Good morning, good afternoon, or good evening, depending on where you are in the world. Welcome to today's DevOps webinar brought to you by TechStrong and Tigera. My name is Jared Harris, and I'll be your host for today's workshop titled Implementing Security Controls on Containerized Workloads in EKS or Self-Managed Kubernetes on AWS. We have an exciting workshop ahead of you, but before we begin, I do have a few housekeeping notes. Today's event is being recorded, so if you missed any of our discussion or you'd like to share it with a friend, the on-demand recording will be made available to you shortly after the webinar concludes with a link to access as well. If you have any questions, we'd like you to submit them in the Q&A tab on the right side of your screen. We do have some interactivity going on throughout, so please be sure to go ahead and ask questions. There, you'll also find the chat tab right next to the Q&A tab. You can communicate with the speakers, your fellow audience members. You can share your thoughts. Just tell us where you're tuning in from. That'd be great as well. There's also some handouts. They're also right next to the chat in the Q&A tab. So if you want to follow along with the slides, download them, do whatever you want, you can get them there as well. Finally, at the conclusion of our webinar, we will have a $25 Amazon gift card for 4 people. Just make sure you stick around so you can hear your name and claim those by email at the end. So we can go ahead and get this started. I'm going to turn the program over to you, Daraj, while I mute myself and turn my camera off.
Thank you. Thank you, Jared. Hi, everyone. Good morning, good afternoon, good evening. Thanks for joining us for today's hands-on workshop. So just to get started, let me start with my slides. Jared, Joseph, you can see them, right?
Yeah, we can see your slides.
Okay. So today's workshop is in conjunction with AWS. So we have AWS team members also with us, Zohaib Khawaja and Dennis Lee. Both of them are here with us. They'll be walking us through a few of the steps with respect to the EKS environment, including for the workshop. So when you are looking at our the workshop, going through the exercises through our demo application and how to build the security access controls, please remember that this is more from the perspective of like how you're using your AWS environment, how you're using your EKS environment as you're building your cloud native applications with microservice architecture. How does the security, container security and zero trust architecture play a role in it, and how Calico can help with it. So just to get started, today's agenda is the introduction, then the container security and zero trust architecture challenges, addressing the challenges. We'll go through these quickly enough, and then the hands-on lab. So with respect to the hands-on lab, as you can see in your chat window, there is a link where you can sign up for calicocloud.io. You'll get your environment for like as a new user sign up for this lab, and then 24 hours later we will basically bring it down. But if you wanted to continue, drop us a note through the chat window or through the product itself, and we can extend it for a longer time. Okay. So there are a few of these links. One is for kick off the EKS provisioning process is there. This is basically posted on tigera.awsworkshop.io, and then Calico Cloud trial, which I talked about. Needless to say, the content will be available after the workshop. It will also be recorded. So if by any chance you are missing a step with respect to following the lab or a particular use case we are talking about or showing, need not worry. You will be able to catch up later on with the recordings and everything. So let's get started. So just as a refresher, one thing we want to mention is like Tigera. You may not know our name much, but if you are in the open source world, you are basically in the Kubernetes world. I'm pretty sure you have come across Calico, Project Calico, right? So Calico open source, that is the foundation for a zero trust workload security. Tigera is the innovator and the maintainer of Project Calico. So with respect to the reach of Project Calico, it works with multiple data planes, right? So if you have standard Linux IP tables or Linux environment, yeah, it will work. We also basically support and fully work with Windows containers also. And then if you have a data plane, which is eBPF based, we work with it, right? So depending upon the complexity and different data planes you're using in your environment, if you're an advanced user, we will be able to support all of them. But if you're just starting a journey and you're standardizing on one data plane out of box, we'll be basically supporting it, right? As you know, the Calico open source uh, project by itself, currently what we have seen is it's running on 2 million nodes. It is powering up on a daily basis like 500,000 clusters. On Docker pools, we are one of the very few ones which have basically become 1B plus, 1 billion plus Docker pools, because we ran out of the million tag there. There are more than 50,000 enterprises who use Calico open source, and many of them, as they graduate and mature their Kubernetes environments, and they're looking for more advanced security and networking features, they basically go with Calico Enterprise and Calico Cloud. More than 50% of the Fortune 100 companies basically use Calico open source or have standardized their Kubernetes environment on premises or on public cloud in AWS, EKS, or other public cloud providers on Calico open source. And it is basically running in a lot of countries. So from Calico open source, let's switch gears to the challenges, right? What we talked about and what this workshop is going to focus on. What we see is when you're building your cloud native applications with a microservice architecture on a distributed infrastructure, on the public cloud one, traditional security is not enough for these applications. The challenges which people run into are large attack surface, right? Like as you have multiple pods, multiple services running in multiple locations, it is very difficult to figure out like, okay, it is not a contained environment, it's a distributed environment, which basically creates a larger attack surface. Another thing is, as person is able to get into the application or is able to latch onto one service, that service might be talking to other services. So there is always this risk of lateral movement. So when you're looking from the perimeter-based firewall approach, this is not sufficient. First of all, the surface area is increasing. It's not just there. And the second is, like when a person enters, how do you stop them, right? Another one is zero-day threats, right? As more and more uh, creative way this attackers are looking to look into the code and then exploit any vulnerabilities in the images, you start to see a lot of zero-day threats. So how do you contain them, which are in your running environment, right? Another one is, as Kubernetes cluster deployments become more complex and people are using it creatively to build more application, more services, they're always looking for a runtime view of vulnerabilities. And these vulnerabilities are not just about like when you're building your container image and then you are looking at the list, but it's more about in your environment, like when you're looking at workload to workload communication, you're looking for vulnerabilities there also, like, okay, which namespace, which pod is basically at risk, and because it is open and talking to some other um, uh, workloads out there internal to the cluster or external to the cluster, how much threat does it pose, right? And then the last one is compliance needs. And then the consequences of these challenges is like high cost of zero-day attacks, right? Do you shut down everything? Do you contain? Do you do failover? Or can you just quarantine that specific area and then keep everything else working? So as the security teams basically focus on containing these problems, it lowers the pace of innovation for them, because as a team, rather than basically chasing the fire all the time, you're looking at even slowing your innovation pace, right? The another one is like as there is always a long list of uh, threats which are being published there, it's very difficult to prioritize, right? Like which one to fix first and which one are not to be fixed. So you need some weighing mechanism in regards to like, okay, these are the top priority problems I have and I need to fix them. And then remediation process, right? Like, okay, if I have found a problem, how fast I can address it, what are the different ways I can do it, and without going through a lot of hoops. And the last one is risk of non-compliance, right? Like if I got a vulnerability, which basically is a threat to a regulated workload, does it mean that I become non-compliant and now I can't do business, or how do I basically go? So from here, what we see is uh, basically different attack vectors come into play for such environment, right? For security. Let's take you through an example, and what you will see in this workshop is there are a couple of them, or 3 or 4 of these vectors we are going to address and show you how you can address them within your Kubernetes cluster. So the way to start is like when you are in the build time, when you're building your images, when you're building your containerized images, you basically start to see vulnerabilities in your images, which can be exploited by the threats. So vulnerabilities basically provide an opening to the threats to come and exploit these images, right? From there, there is another way of this is like misconfigurations, right? Misconfiguration where some security aspect with respect to the passwords, respect to the IP addresses or something has not been followed or has not been properly skewed, that also becomes a threat which can be used to exploit. Then from there, this is generally about the containerized images, right? But when you go into the Kubernetes engine, you are looking at that Kubernetes orchestration itself as an engine. Like, can there be misconfigurations in that environment, right? And then that will also create threats within the environment. That's where it comes out. So from here, when you are into the runtime, like when you are running your nodes or your application within the EKS cluster, what you start to see is runtime threads within the workloads, right? Like, for example, if an application is a hipster shop and it has uh, 2 services running, the payment card service and then a checkout service, and there are images in it, what you will start to see is there is a vulnerability or malware present in that. So that becomes a runtime threat in the production environment. From here, you also start to see is that most probably that payment service or a checkout service is talking to some external service or third party API to basically make the business workflow executed, right? So that's where there is another threat which comes into the play is of the granular egress access control. That is my service within the cluster open to everyone, which basically creates this situation of like anyone can access that service, and from there they can move inside my application and then cause a lot of disruption. Another one is many times people have a lot of their data on premises or regulated workloads behind traditional firewalls. Like, how do you make sure that your uh, cloud native application running on Kubernetes is able to talk to this traditional firewall and not open up all the IPs? Because on one side, the IPs are changing all the time. And on the other side, the firewall is basically working with one IP, right? Like, so do you basically make it open to all services which are running in cluster, which creates a problem towards your database, or you basically find a way or do everyday mapping on it, right? Another one, what we see is a zero-day threats, right? Like if, and by any chance, nothing was detected all along and someone found a problem or a vulnerability within an image which exists in a production environment, um, and it is there, how do you basically fix it? The last one is threats from malware and the ransomware. So when we look at the different attack vectors, what we see is the security is needed end to end. It is needed during the build time, deploy, and runtime, because you can have attack coming on your application at any time, and then y- it needs to be protected in all these 3 phases. So how do you do it? How do you do with Tigera and specifically with EKS, right? First is we reduce the attack surface with zero trust, right? We provide zero trust workload access controls. Like your workload will only talk to the service or a third-party API, internal or external, to who you allow, right? Identity-aware microsegmentation. So if you're doing any zoning uh, for basically making sure that regulated workloads are compliant for a specific zone, the other workloads can talk to different set of services. You can do all this identity-aware microsegmentation based on labels. In regards to the firewall piece, we provide a universal firewall integration. So you can have any type of firewall, and then you can use our egress gateway with it to make sure that your cluster, Kubernetes cluster, talks to your database, but it is all automated. So you don't need to worry about the accessibility there. And the last one is providing Envoy-based application level security. So that is one piece. So we reduce the attack surface, so you can do that. But then we also provide you capabilities to detect the known and unknown threats, right? Like you are able to look with our platform uh, into like protecting your workloads from container and network based threats. So there are threats which are internal, so you need to be alerted for them. But then as you're talking to the outside world and everyone is trying to access your application, how do you basically are able to get alerted about that? So for that, we provide workload based WAF. We provide IDS IPS with deep packet inspection. uh, we are looking at different type of vulnerabilities and the threats which are coming in, and then we are able to alert you with respect to the zero-day threats there. And then we also provide malware protection. But when you're looking at the piece of like, okay, being proactive with respect to like reducing the attack surface, then making sure you are able to detect known and unknown threats. The last piece is, if the security threat is present and you need to basically address it right away, we help with automatic risk mitigation. And one of the ways, as you will see in the workshop, is dynamic service and threat graph. This is a live visualization of your Kubernetes cluster. It can have as many namespaces as there are. You have it, it can have as many workloads running. You will see all the communication happening there. You will get all the alerts with respect to all the communication which are failing, or the workloads which are prone to basically the attack. And then from there, with the automatic, when you get that live view, what you get with that is, as soon as you click, you are able to basically build a security policy around it, right? So you can quarantine it, you can kill it, or you can terminate it, right? And the last one is, when you're in the build time and you're trying to make sure that only the images which are clean or according to your standard, we provide admission controller which basically makes sure that only the images approved by the team are able to get in, and then you can build policies around it. So going through the features of Calico Cloud, which will be used in this workshop with EKS, um, are going to be like the image assurance one, where you will see the registry scanning, admission controller, and then runtime view. But then we'll go through some policies to secure the environment, to help you like how you do compliance, and then also build some of the access control based on zero trust, and further going into a little bit of runtime threat defense. But all will start with observability and troubleshooting, where you will see first how your EKS cluster looks like. How does an application within EKS cluster look like? And from there, you basically start to take security-based actions. So with this, I will just skip these slides, I think, so for the interest of time. Uh, Calico Cloud is based on Calico open source. It has a lot more capabilities, as I skipped a couple of slides, but these slides are available for you. You can try and buy it. You can subscribe it through AWS Marketplace. We have a 30-day opt-out option there, so you can literally go in there and then try it in your environment. You can have a sample cluster connected right away, and then you can evaluate it. So with this, I will hand it over to Joseph from here onwards. Joseph?
Okay, thank you, Diraj. Welcome everyone. Let me just start with sharing my screen. So today's workshop will be focusing on just security observability using Calico on EKS. So as Daraj mentioned, we in our agenda we started with talking about the challenges of the container space and Kubernetes and how to fix that using Calico. Today we will be working mainly from two resources. So first thing we have the workshop content, which is tiger.awsworkshop.io. I have shared that with you on the sticky note on the chat. So let me open that here. And here we have two versions. We have version we added with event engine, ends with 2 E's or EE. And there's another version just tiger.awsworkshop.io. And the difference is that today AWS are providing a temp AWS account for all the attendees where they can use AWS clustered with Calico. They are providing a Cloud9 instance with a pre-configured EKS cluster. So with this setup, we will go through this workshop content, how to set up your temp account and continue the workshop. In case that you have your own AWS environment or you want to go through this lab later on with your account, you can just use the normal link, which is awsworkshop.io, and that will guide you through the steps of installing the EKS cluster on AWS, then connecting that cluster to Calico Cloud and doing the use cases that we're gonna do today. So with that, I will hand it to you, Lee or Zohaib, just to introduce how we will set up the environment, or I can guide everyone here. So up to you.
I can take over from here. Again, hi everyone, I'm Lee Smith. I'm a partner solution architect here at AWS, and I'm going to share my screen here so I can walk everyone through accessing Event Engine here. Now I'm going to post into the chat as well the link for the dashboard for Event Engine, and then I'm also going to give you this event hash ID, which is what you need to log in. And that's going to be in the chat as well. So when you have those, you'll be able to follow along with me. So again, the event engine is where you're going to be able to access the AWS console and the temporary accounts that we have for you. Now, I've set them to run for about 12 hours. So even if you kind of want to play around in that account a little bit after this, you feel free to do that. You know, we're going to provide that to you all. Now, once you get to this screen, you're going to put in that event hash ID, and you're going to accept the terms and conditions for that. Now, for mine, you're going to see they logged automatically in there. What you're going to have, and I'll actually show you from here, is you're likely going to end up, oh, no, it's actually not there. Well, what's going to happen is it's going to bring you to a screen where you're going to possibly have to authenticate with a one-time password that you send to your email, or you're going to log in through your personal Amazon account. So whichever one you choose for that is going to send you the one-time code, or you log in through your personal Amazon account. And then once you're able to get into that part of it, you're going to click on the AWS console, this button here. And that's going to take some time to load up here. And then you're going to click on Open Console. Now, of course, you have the ability to access through the CLI, but we recommend just go through the console for here. And once you click on that, it's going to start opening up that AWS console for you. And that'll bring you into the console. Then from there, you'll be able to kind of follow along through the workshop. So again, just kind of to go back over that really quickly. I posted the link into the chat for the dashboard for Event Engine. You're going to log into there. You're going to provide, let's go back here. You're going to log in there. You're going to provide that hash code, which I also put into the chat. It's going to give us what starts with the BCF3. And then if you have to authenticate through a one-time password, you'll provide your email address. That'll give you that code, or you can log in with your personal Amazon account. And that way you'll be able to access into here. You'll click on AWS console. And again, that's going to open up this to where you can click that login link, and it's going to open up the management console for you. And with that, I'll pass it back over to you.
Thank you, Lee. So I also have added the workshop content and the dashboard link in the chat. I'm sticking it in the chat. So I'll share my screen again. And okay, so once you are in the console, you can just go to the search bar and go to just try Cloud9. So you will find an EKS Lab IDE ready for you, Cloud9 instance. You can just click Open IDE. And in few seconds, we will get access to the IDE environment. So if we go to back to our guide, just show you where we have all this information in the guide. So it's under Event Engine setup. We just logged in using the dashboard. We get access to the AWS management console. Then we navigated to the Cloud9 and we clicked Open IDE. And the next step, we will just, usually the Cloud9 comes with default AWS authentication. We have a pre-authentication configured here in this lab, so we need to disable the default one. So, and here we go. So from this screen, from the AWS Cloud9, we will click on the settings here, and then we will go to AWS settings, and you just need to disable AWS managed temporary credential. This is a default AWS temporary credential comes with a Cloud9 instance. So we don't need it for this lab, and then you can just close and just you may increase the working area. At this point, we can just check the existing cluster. So if we run kubectl get nodes.
Hey, Joseph, just letting you know your screen share isn't on right now.
Oh, something happened. Let me share my screen again. Can you see my screen now?
Yeah.
Yeah. So we have one more step to do. So if you are able to follow me, once you get here and we disable the AWS temp credential, you need to copy and run this command to your terminal. Just that will download all the utilities and tools that you need, that we will need it in this lab. So simply when I tried something like kubectl, is wasn't there. So we need some tools to be just pre-configured in our environment. I think I don't need this one. Yeah, once we have that installed, you can test the access to your cluster by running kubectl get nodes, and you should find 3 nodes ready in your environment. Okay. Meanwhile, I will ask you as well to sign up to Calico Cloud. So to go to our Calico Cloud portal, just try calicocloud.io. Okay. And if you already have an account, you can log in from using existing user. If you are new to Calico, or maybe you tried it before but your account has been expired, you need to sign up with a new account. Just click on Start Free Trial and click your email. Just try to use an email you didn't try before with Calico Cloud. So if you get if you already got the trial account before, you will not be able to get it again. So you have to try a new email address. So just try your account, give it a password. Okay, and you'll get this welcome message, and you should get an email in your mailbox.
Hey, it's Zahib here from AWS. Just wanted to let everyone know it usually takes 2 to 3 minutes to get that email. It doesn't typically happen instantaneously. So if it takes a couple minutes, that's normal.
Thanks, Zahib. So I got my email. This is an example of the email. You get your account and verification code. You need to click on this verification code, and it will take you to this page. The email has verified. Just go back to Calico Cloud. Okay, and after that, because I already have an account here, so I logged in directly. You may need to just fill a quick form about some information, what use case you use, and what environment existing, what platform you use. Some just quick information, and complete the sign up process. Once you log in, you will get to that view. You may be asked for some getting start question, like this is a kind of tutorial to explore flow visualization, explore cluster traffic, connect to your cluster, and so on. So once you have this account ready, we will connect our EKS cluster to Calico Cloud. So let's go back to our EKS environment and see if everything is installed. So the script is ready now, and all the utilities has been installed. kubectl, git nodes, and as you see, I have three nodes now up and running. So let me stop here and ask if everyone following me, is there any questions? Okay, so the next step is to connect your cluster to Calico Cloud. So once you log in to Calico environment, you have a menu on the left side. You can expand this menu from these 3 lines, and you go to Manage Clusters and Connect Cluster. Give a name to your cluster. So I will name it AWS Workshop. Just avoid to start use your naming with cluster, word cluster, or Tigera. Just name it anything else. And from these options, I will choose Amazon EKS. Then next, and here are some requirements about what's required for your EKS cluster to connect to Calico Cloud. As your environment is already pre-configured, so we are meeting all the requirements. And here we have a link. We use it to connect to your to connect the cluster to Calico Cloud. some reason I'm getting error. I'll try again. Okay, here we have the script, the operator that we will use to install Calico in your cluster. So I will go back to my environment and I will paste. Okay, so at the moment, Calico controller is installing Calico component in the backend. You can watch that. Usually takes 4 to 5 minutes. So you can just follow or check the status of the installation from here. So this is the name of my cluster, AWS Workshop. You can expand this. It's currently installing, and you can see the logs here of the installation process. So if you get any error or if the installation is not completed for any reason, you can understand why this is happening. Another way to check the current status of the installation, you can use kubectl get Tigera status. We can just run it in watch. Okay, you will start to see the different components of Calico coming up here now, as you can see. And once we have the status of the availability true for all the components, that means that our cluster is connected and ready. And if you go to the UI, you should find the status, change it from installing to connected. Meanwhile, we can go back, as I told you, that may take just 4 to 5 minutes to have your cluster ready and connected. Okay, so in our content guide, so we completed the process of initializing the EKS cluster, and then in Calico Cloud, we followed the steps to connect our Calico environment to our EKS environment to Calico Cloud. Here's an example of the script that we copied. This is the status of the installation. As I told you, when you're on kubectl get Tigera status, you see different components are coming here: the API server, the Calico component for networking, compliance, intrusion detection, the load collector, the management cluster, and the monitor component. Once you have the availability status is true, that means that everything is running correctly and the cluster is connected. We have some configuration we need to change here for the purpose of the lab. So some few tweaks we do to speed up the process of the log collection and the log flush interval for the purpose of this lab to expedite the status of getting the status from the cluster. So I will copy this and go to check the status of the cluster. Okay, so now the API server is true. Once the API server is true, we can run our configuration tweaks. So I'll just exit that. We have another useful command here. Okay, so we configured our environment. I will go back to watch kubectl. Okay, so now we have everything true now. That means that the installation is successful. Let's go to the UI. We can refresh the page now. And it should be, okay, here we are, AWS Workshop, states connected and done. Okay, so now we can start working with our Calico environment. Let's go to our modules and see what we will do. Module 1 is to configure and secure our demo application. Okay, to start with, the nature of the Kubernetes is that it's a platform where by default all the connection is allowed. It has a very high large attack surface. So to start with, we need to limit the communication between the different application in this platform. So the first thing we do today is to create some tiers. And the idea behind the tiers is, in any environment, we have different teams. You have a platform team, security team, and the DevOps team, and the developers team. So how to get all these teams to implement security policies in your environment and without any conflicts. This is how where we use the tiers. Let's deploy this first, and I will show you the result of that. So I will just create the tiers. One more thing here, that if you do ls-l, we are actually all these examples on our GitHub repo. So we just, as a part of the script that we run at the beginning, we downloaded this repo to this Cloud9 environment. So we need just cd to Tigera EKS workshop, and then we can run. Okay, so now we created two tiers, the security tier and the platform tier. I can simply just show you the manifest of this file. How do I stop? Okay, share stopped again. I don't know what happened, but for some reason the share is stopping. But okay, back again. Okay, so simply it's Project Calico API version, the kind is tier, and you give it a name and you give it an order. So the order of this tier is 400. The order of the platform tier is 500. And when we go back to Tigera, from the upright here, you can just switch. If you have different clusters, if you are connecting different clusters, you can switch between clusters from this drop menu. I will select AWS Workshop, and I will expand on the left side here and select the policies or the policies board. And here you see the 3 tiers. So these are the 2 tiers that we have just created, the security one and the platform one. So these tiers is where we build the policy. So we create the policy into tiers, and we can tie each tier with an RBAC to a specific team. So you tie the security team or the security tier to the security team, and the platform tier to the platform team. And policies get evaluated in this board from left to right and from top to bottom. So that means security tiers have a higher priority than the platform. So because security tier will be evaluated first. We have some other tiers here, but it's hidden by default. Something like allow Tigera, and this is default policy that we have to allow the communication of the EKS cluster to Calico Cloud. And we have the Tigera security, which is by default IB threat feeds enabled in your, once you connect to your cluster, to deny the traffic to unknown malicious IBs. You simply can just switch between these tiers or between the policies. So back to our lab here. So once we have created the tiers, we want to create some policies for the platform tier, And what we need to allow now, the first thing is to allow the DNS connectivity into your cluster. So this policy is to allow the DNS connectivity. And here you see the allow cube DNS policy created. I'll just hide this to default policy just to make the view simple and everything we create. So this policy, we are just allowing the traffic from the cube DNS over port 53 to all the clustered in the environment. The next step now, we will deploy some applications. So we are deploying a dev app and a hipster shop boutique application. And hipster shop application is an e-commerce application. It consists of 10 microservices. I have the architecture of this application here. So simply we have a front-end application where the traffic comes from the user. There's a load generator just to simulate HTTP traffic coming from different user to the front end. In this application, it's an e-commerce application where a user can go to select items from the product catalog, and he gets recommendation from the recommendation service. He gets some ad from ad service. He can add the component or the products to cart, and there's a cache service to cache these products, which is Redis cache. User can add shipping service and check out and just change the currency. Once he checks out, two servers are used at the payment, and he gets email confirmation. So this is simply how the application works. And so we are just deploying this application in one namespace called hipster shop, and we have another namespace called dev. We have just two bots there, the CentOS one, Nginx one. We are using these two bots just for testing the connectivity between the different workloads in our environment. So by default, when you deploy any application or workload in your environment, traffic is allowed between anything. So we will start by limiting this traffic now. Just before this denying the traffic, we will learn some component that we will use it later in this workshop. So we have some compliance reports where you can get CIS benchmark reports, inventory reports in a daily basis or in a weekly basis, however you configure it. We have some global alerts we deploy it in our environment. And one more thing you can enable is to enable layer 7 log collection. So in order to get observability on layer 7, we deploy a kind of, or we rely on Envoy proxy as a daemon set. So we are just deploying this custom resource. So this custom resource called application layer, which deploys a Envoy daemon set, and we rely on this Envoy in mainly 3 functionality. First of all is application observability, layer 7 or application level observability. The other thing is to use WAF or web application firewall between the different components inside your cluster and for the incoming traffic to your cluster. And the third capability that it's still tech preview, it's coming in the next release, is application layer policy, where you can block certain layer 7 or HTTP verbs like post or delete or get just control this HTTP verbs. So once you enable application layer, or it's in the backend, it deploy the Envoy proxy, the next step is to annotate which service you want to allow the layer 7 logging. So in this example, we will annotate the front end service and the checkout service to make it a layer 7 logging true. So even you can select which applications, which pod you want to enable layer 7 logging. Okay, so here at this point, we will start to segment the connectivity within the cluster. So we will start with testing the connectivity, and then we will deploy some policy to deny the connectivity. Just in order to start our test, I'm installing curl to the load generator to the load generator board. I'll be using it for testing. Meanwhile, we can go to our UI, just to the service graph, and service graph is point-to-point topology, where you can see all the traffic coming to your cluster between all the services. We see the dev namespace, we see the hipster shop or the default namespace. Let's just double click on any namespace and see what we have there. Okay, so in the default namespace, we deployed the hipster shop application. If I increase the resolution here, you can see the front end, and you see the load generator talking to the front end. You have the different servers, checkout, the ad server, the shipping, the currency, the email, the product catalog, everything happening here. You can, even if you want to clear this view and some of the Tigera component, you can just click and hide these namespaces if you don't want to see these namespaces. And once you have the view that you want, I just don't want to see the cube. These things I don't want to see. The private network, just focus on my application. And once I have this view, you can simply save this and give it a name, and save it. And at any time you just want to have a look in your connectivity, what's happening, you can just click on any link between two servers and get all the network flow, and the network flow that includes all the connectivity, all the parameters in terms of source IP, source name, aggregation name, namespace, the label that associated to this source, the destination IP, the label associated to the destination workload, what policy has been applied till we reach to that decision is to allow or deny, and even you get the level of the process name and all this information from this flow. So it's very helpful and it's very handy. Back to our terminal. So we will start with just, at this stage, we are just doing some tests to make sure that all the connectivity is allowed. Because of the time, I'll not go through all the testing, but everything should be okay, because by default, everything's allowed. We are not denying any traffic. So in this test, we are testing between workload within each namespace. So here from CentOS and dev namespace to Nginx and dev namespace. And in this example, from the load generator and the default namespace to the front end. The other test is to test connectivity across namespaces. So from the dev to the default, and from the default to the dev. And the third one is the test connectivity with internet connection. We are just testing from CentOS to Google, and from load generator to Google, and all the connectivity should be fine. We should get an okay reply for everything. So to start with, we can just apply or a staged default deny. And staged default deny policy is a good way just to block any traffic that is not matched by any configured policy to allow this traffic. So once I will apply this policy and go to the UI, you can see this policy here is default deny, and you can see that the status of the policy is staged. And staged means that we are not actually denying the traffic, but you monitor the impact of this policy. So it's very handy that before you apply any policy, you keep it running in a staging mode to monitor what is the impact. So we see that if this policy applied, we will start to get some denied traffic. You see the red denied traffic, and if you go to the dashboard, you will start to see some denied traffic here because of the default deny policy. So if you apply policy and you're not expecting this policy to block anything, and you start to see some red traffic here, so you know that there's something wrong with this policy, and you need to fix that before enforcing this policy. And so yeah, and this stage, before denying everything, you need to deploy this policy. And we have two manifests, one for the policies in the dev namespace and one for the boutique shop or the hipster shop application. Before applying that, I want to show you that even you can just get some recommendation for your policy. So you can just ask for recommendation and select your namespace, for example, the default namespace, and select add service. And based on the traffic that Calico monitored in the last few minutes where we run the cluster, we see the recommendation is to only allow ingress traffic from the front end to this add service over port 9555. And it's very handy. You don't need to get experience with YAML and policy configuration. So you can start with the recommendation, then see how everything will work, because usually in most of the cases, the developer team are not providing a clear table with which port ingress and egress you need to enable or disable. So you can just go and click enforce, and the policy will be applied. But in this case, I already have the list of policies, so I will just apply these policies. And when you go to the policy board again, you see all the policies applied in this default here. At this point, if you test the traffic again, just before testing the traffic, I will go to enforce the default deny policy. And the result of what we did exactly now, we allow the traffic inside each namespace between the different policies, and but we are not allowing explicitly any traffic between the different namespaces or with the external. So when you test the traffic going to external, that should be blocked. When you test the traffic across the namespace, that should be blocked. The only thing now working is the connectivity between services inside the namespace. Just I need to check off the time. Our lab is long, and that's why we are giving you 12 hours to continue the lab, to go through all the use cases, and even you have the content later on if you want to use it with your own cluster. So let me ask back how much time we have.
We've got just over 30 minutes.
Okay, so we still have 30 minutes.
Yes, sir.
Okay, thank you. Perfect. So at this point, we block the traffic. And okay, I'm not on mute. At this point, we deployed some policies. We can go through our testing as we have some time. So let's start with testing the connectivity inside the dev namespace from CentOS to Nginx, from Load generator in the default namespace to the front end. and this traffic should be allowed and okay as expected. And now we will test the connectivity across the dev and the default. So we are just testing from CentOS in the dev to the front end in default, and from load generator in the default to this is Nginx in the dev. So it's both ways. And as you see, connection terminated. So there's no connectivity now between the different namespaces is allowed. So simply, we are just allowing the traffic between the different components inside the hipster shop namespace, but anything between these namespaces is not allowed. The last test we have is to test the connectivity with external resources like Google in this example. And again, there's no SaaS traffic allowed in this case. And this is a very good start to secure your environment. We have an example here to deploy global thread feeds, and where you have a list of malicious IPs that is you want to deny the traffic to these IPs. I will leave this example now. I will get back to it later when I will talk about network sets. So I will jump to securing the egress traffic for a specific workload. So we have tested the connectivity between the CentOS and the front end, the two different namespaces, and we have seen that this traffic is denied. Just to double check. It's not working. So and again, on the egress level from the CentOS to the Twilio and Google, again, that should not be working. Okay, so now we will deploy two different policies. The first one, we will deploy egress traffic to allow, egress policy to allow the traffic from CentOS to the front end. And we can have a look on the configuration of this. Just, yeah. So we are deploying this in the platform tier, and you can see from the naming, we just tried the tier name dot the policy name, and it's in the dev namespace. We are using label selector app equals CentOS, so we are applying that to the CentOS, and we are just allowing egress traffic here. This one for the DNS because it's just by default, but this is the most important one, is that we allow TCP to the application called front end and in the default namespace. So now once we apply this, if we go and test the connectivity again from CentOS to the front end. So this is an example of just configuring a policy for a specific traffic to cross the boundary of the namespace. So sometimes you have a development namespace, and where you need to run some tests on a different namespace. So you can allow certain traffic using the egress policies. Another example of deploying the egress policy is just integrated with the DNS policy. So we tested before the connectivity from the CentOS to any external resource, Twilio, Google. You may have some resources in Amazon S3, buckets, database, any external resource, and you may want to enable DNS traffic. So by default, DNS, you can't create a security policy in Kubernetes just using the fully qualified domain name. But Calico facilitate that and allowed you to create a DNS policy using the fully qualified domain name. So this is the policy that we have. And again, I will just open this policy, and you see that in the egress traffic we added an option called domain, and we even using the wildcard just in case anything under the twilio.com, the APIs has been changed that doesn't impact your application. So that's how we enable the DNS traffic. And now if you test, you will see that the traffic only to API Twilio is allowed, but the traffic to Google is not allowed. We can see that in the UI under policies. This is the policy that we have just created, which is allow Twilio access. And if you go there, you see this is the domain or where you can add the domain. So you can everything you can add it from the command line or from the UI. Even if it's easier to you to configure from the UI, and you can just go and edit whatever you want to edit here. So you can just add more domains. So here, just go and add more domains if you want, and you can simply just download the YAML file and just save the YAML file. So that's very handy. Everything you can just even you can integrate everything with your CI/CD pipeline or just use the UI. It's all up to you. Yeah, one more thing. So we have seen how to allow DNS policy by editing the security policy or the egress traffic into the security policy. But once you have more policies, once you have more external resources, you may need a different way to manage your domains and how to allow the traffic to the external resources. And that's where we use something called network set. So I will deploy this YAML file first, and then I will describe what is the network sets. Okay, so the network sets, when we go back to the UI and click on the network sets from the left menu, and we expand, we have just created called external APIs. So external APIs network sets it's kind of a container, or like it's organization unit or group where you can group all your domains or CIDRs or IPs under one place and give it a label, and then reference this label into your policy. So imagine that if you have 100 policy using the same external resource, and the domain has changed or the IP changed of this external resource, you don't need to go to all these policies and just edit that in each place. So you can just edit that in one place in the network set and reference that to the network policy. So here the label is type equal external APIs. If we go to the policies and we go to the Twilio axis, right, we see that we are not using the domain name itself again. We are just using the label of the network set. And this is very handy and useful in different use cases. One of the use cases that I talked about, or one of the use cases that I've just skipped, is it's here. yeah, the thread feeds or the thread feeds trackers. The thread feeds work the same way as using the network sets. So I will copy this manifest, and so what we have just created, we created two resources. We created the thread feeds feeder trackers, and the thread feed actually is just a network set. So we created a new network set, but this network set get updated every day with the new IP. Sorry, this is the one. So it depends on how you configure the thread feeds, but every day this network set go and get this new malicious list of IPs, and then we have the label. Then we go to the policy. We create a policy called block field tracker, and we reference that to the network set. So this is another implementation or another use case for using the network sets. Once we go back, yeah, this is an example if just blocking the traffic or making sure that pinging one of these IPs or one of the malicious IPs will be blocked and will be reported in the UI. Okay, so do you see 0 packet? We are just pinging this IP. If you go to look this IP, this is the first one in the feeder tracker, and it was 118.0.53. It should be here, 118.0.53, and the traffic is not allowed, and you will get this in the dashboard in a second, and you can see also in the service graph, and you can configure different alerts here to see to get these alerts. So we have some alerts here. We will talk about these alerts later on. So now we have limited the attack surface. So we have restricted the traffic inside our cluster in both ways, all the incoming traffic to our cluster and the traffic between the different services. The next step is to secure Kubernetes host itself. So you can use Calico to secure the node itself where you have the Kubernetes engine running. It's either if it's physical machine or virtual machine. It's in our case it's EC2 machine running in the background for your EKS, but you can simply do this. The first step here, I will not go completely in this use case, but you can simply doing it. I can just start with showing you where you can and how it works. Yeah, so we can simply just run these commands. So the first command is to check the current status of the host endpoint auto creation, and it's by default disabled. And once we enable host endpoint, just before enabling it, I want to show you in the UI, when you go to the endpoint here, you get list of all the endpoints, and you see it's the type is containers, all the containers in your environment. Once you have this host endpoint enabled, when you go to back to the endpoint list, you see 3 hosts here and 3 network interfaces, and this is actually the interfaces of the 3 nodes that we have. And you have a label list. You can add label to these nodes and apply network policies. In our example, it just we have script at the beginning just because you need to allow the traffic to security policy on the EKS side, and then just before doing this. So just for the sake of the time, I'll not go through this process of it's scripted here, but just I will leave it for you to, if you want to go through it, just make sure. But this is how it works. We have another command to see what host endpoints we have. So you have three endpoints. So we converted the physical interfaces in these nodes to an object in Calico, where we can assign a label and use this label to apply policy. The next use case, so this is all about the host endpoints configuration. So the next module here, we will be talking about the tools for observability and troubleshooting. So we have different tools. You have seen that with me in the last module. There's a dashboard, the policy board, the timeline, the endpoint, the flow visualization, the Kibana. So I'll take it one by one with you. So let's start with the dashboard. And the dashboard is the first thing on the left menu, and where you have a widget for different statistics into your cluster. You get the total number of policies you have, the traffic, the allowed traffic in green. If there's any blocked traffic, will be showing here as red, or the denied traffic. We have total number of alerts here. We are getting some of alerts. If you schedule any CIS benchmarks, once the report is available, you get the quick the number of reports, number of available reports. You can see number of nodes in each cluster. You get the number of connection, the allowed bytes and packets, the denied packets and bytes. And you can go to the layout and enable, for example, if you enable WireGuard for encryption, you can just see the number of encrypted traffic into your cluster. The next thing we have after the dashboard is a policy board, and I think we spend much time in policy board. I have described to you how the policy get evaluated in this board. So it's from left to right and from top to bottom in each policy. So that means that security policy will be applied before anything related to platform or the default or the dev team. We have seen how we use the recommend policy, how to ask for recommendation. We can export. This is YAML file for all the configuration of all the policies. You can add tiers, the tier that we have just created, and you can just customize the view. You see the pass traffic, the denied, the allowed, the endpoints. And this is a different tier that you have. The other tool that we have, so audit is one of the powerful tools because of it's very required for compliance and regulation purposes. So if you go to activity and select timeline, you will see a list of all the changes in your environment, and you get the timestamp and the account who created this change and what happened exactly. So you see the policy called security block further tracker had been created, and if you click here, you get the YAML file of this change, so you can understand what applied exactly. And if you want to roll back, you can easily roll back this change. And this list of IPs that I have that has been automatically updated for the thread feeds This is we created Twilio, and not just that, you can compare the change. So the timeline is one of the tools, but if you go to the policy board, if you select any policy, something like the Twilio axis, and if you go down, you see the list of a change or change log for this policy. So you can create, you can click on this one. You can download the YAML file, or you can click compare, and you can split the view and see what has changed in this change. So what happened to the YAML file? You see that 2 lines has been removed, and this line added, this line added, and this line has been removed. So you can easily understand what happened is in this cluster, and who created that and when. You can even export all this data to any external same solution, or any external repository where you want to keep all these logs. The other thing is the endpoints. We talked about the endpoints. You have 2 tabs here: the endpoint details, where you get all list of all your containers, and both you can filter using the node or policy name or labels you have. Different filtering capabilities are available here, and you can also just expand any of these containers or pods to get list of labels associated to it, policies, how this traffic gets evaluated, and again the node where the pod is located, the pod name, the full name, IP address, and the interface and namespace. You can switch to the node list. So the same thing, we have 3 different nodes. You get list of endpoints on these nodes, and number of pods running in each one, the number of packets sent to each one and denied on each in each node, and the connection. So if there's something weird happening and so it's that your pods is not well distributed between the different nodes, you can notice that here. So after that, the service graph. The service graph is something very useful, and you can use it every day. So when you click in the default, you get an overview about all the namespaces in your environment, and the different connectivity between the different namespaces. And any green line represent allowed traffic, and any red line represent denied traffic. You can just double click on any pod and get more visibility into this pod, into this namespace. What the traffic is traveling between the different pods inside this namespace. If you select any traffic or any endpoint, any pod, you can get list of the flow logs between this pod and the different pods, number of flows, the action, the resource aggregation, the name of the source and destination. You can expand to get more information. Even I showed that before, the protocol, the labels, the policies, how it gets evaluated, the processes inside the process number. We try to differentiate between the flow logs and the DNS, because DNS is one of the most headache component that we see that may require a special troubleshooting or special traffic analysis. So you get all the DNS logs here. We have HTTP traffic as well. So I think we enabled HTTP traffic on the front end. Let me select the front. No, not the external one. Anyway, so I don't remember. I think we enabled for front end. We can get back to this later on. But if you enable HTTP traffic and you annotated the service, that should be populating here. If there's any alerts, should be there, and the back capture, we'll talk about it later on. You can expand the right menu here to see how the traffic gets evaluated. A point between 2 points, number of allowed traffic and denied, and what protocols exactly allowed between these two boards, what policies has been evaluated this traffic. You can get more insight about top URLs, the HTTP states, and the process info. All this information would be very helpful for you when it comes to troubleshooting. And the next thing is the flow visualization. Flow visualization as well as something under the service graph, so you can simply just understand. I see that very useful. So dev team, they push application every day and you don't understand what is talking to what. So you can simply just, if you want to select the default namespace and you see the different flows into this namespace. So you can just expand here. You see, okay, I want all the connectivity with the front end. And you can see that front end is talking to the core DNS and there's a private connectivity going to the front end. You can simply just check out service and you see all the flow logs between the different services visualized in front of you. So that the three circled simply, the first one, the outer one represent the namespace. The secondary one is the pod or the application itself, and the third one is connectivity or the flows inside this with this pod. And again, you get, once you select any traffic, you get the full information about the allowed traffic and denied traffic between these endpoints. So it's another very handy tool. Yeah, Kibana Dashboard, and Kibana Dashboard is shipped for free with Calico Enterprise and Calico Cloud. And once you click on Kibana, we have some dashboards are pre-configured for you. So if you want to deep dive into the filtering the traffic inside your cluster, understanding, troubleshooting what's going on, you can simply go for something like dashboards. You have, let's select the DNS dashboard, and you can get some visibility on what's going on in this cluster. You get number of queries, the top external DNS has been called. So you see the Twilio, the API Twilio that we use to test, and the Google. You see the DNS response, the DNS requests happening, the interval of response, the latency, and at the end you see all the flow logs here. You can even filter anything you want. So you can just say add filter and just client name equal is, for example, CentOS. And save, and maybe we don't have anything for CentOS. Maybe we just click this one. Yeah, maybe you need to select this. So I mean, just you can play a lot with this. Just we are running out of time. We have maybe 1 minute, so you can just simply filter the traffic here, and go. And yeah, the last thing I want, we have 2 more modules about the reports. We run some of reports, but the coolest thing I want to show you is the packet capture. Packet capture in Kubernetes is pain. So simply, if you want to do a packet capture in any pod, you can, using Calico, you can just right click and initiate packet capture, give it a name, set a schedule, and you can schedule it in the midnight if there's something happening there, or even you can configure alert to when something happened that triggers packet capture. You can filter what traffic you want to capture, and you just run this, and the packet capture the jobs will be ready for you here. You can just stop the packet capture. You can start it again. You can download the YAML file. You can download the packet capture itself. You can delete the job or delete the capture. Just I can show you the YAML file quickly. So it's again, it's a custom resource called packet capture, where we just select the namespace or we select a specific port. We filter based on port or protocol. We give the schedule and just run it. So that was simply yeah. I'm sorry that the workshop may take longer, but we covered a few things here. This is the packet capture, and finally you can just, the last module is about compliance reports, so you can run CRS benchmark compliance reports in your environment. Here the configuration, and that will be under the under the compliance reports here. So cool, we have some reports already running. So this is some example for the inventory and network access reports. So by saying that, I think we are reaching the end of our session. So I'm happy to see if we have any questions coming.
I believe Lee and I believe Lee's been answering most of them in the chat. But if anyone else has any more questions, go ahead and submit those. Otherwise, we can start closing out. All right, then I'm going to start closing out, Joseph. That was outstanding. Thank you so much. I want to thank you and Diraj and Lee for taking the time to join us to share your expertise with us and go through your platform. Just a quick reminder that today's session was recorded. Following the panel, you'll receive an email with a link to download the recording for the on-demand. In the event that something happens, it doesn't come, or it gets misplaced in your spam filter somewhere else, you can always go to devops.com/webinars, look in the on-demand section, and you can find it there as well. Just want to point out again, we do have 4 $25 Amazon gift card winners. They are Dilip S, Bandar S, Cliff Z, and Venkata E. Congratulations to the 4 of you. Please keep an eye out on your inbox for your gift card. If you don't receive it, again, check your spam filter. They have been known to show up there from time to time. Joseph and Diraj, thank you again for taking the time to be with us. I'd also like to thank Tigra and AWS for sponsoring this webinar. I also want to thank each of you for joining us and staying with us for the entirety of the presentation and commenting and just being with us. If you could, please take a moment as soon as the workshop ends to fill out our survey. We would greatly appreciate it. And I will be signing out. Have a great day.
Thank you. Have a good day.